before, and here's the after. Alright, well let's get started designing this brand new, more reliable board. Let's get into some pedal boarding. And before we get started building anything, we need to come up with our plan, which is going to start with a list of requirements. So here they are. First requirement is that the board has to have two inputs because we're going to be swapping between an acoustic and an electric guitar. Those inputs then have to be selectable, and they have to be selectable really easily, especially considering the signal path after both of the inputs. So it has to incorporate all that. We also have to have a volume pedal and a tuner that work on both guitars. We have to have stereo outputs because we're going to be incorporating an HX stomp pedal that has stereo effects. And the whole board has to be able to fit over a keyboard stand leg and tuck under a full-size keyboard. This is a keyboardist who also plays guitar as part of a local cover band, so we need something that works for his setup. And now let's start to plan out the signal path. This project comes to us with all the pedals for the pedal board already being selected and already being provided. So it's our job to put this all together in a signal path that really works for all of the requirements and for this project. Let's take a look at the signal path itself. We have an electric guitar coming into the board and an acoustic guitar signal coming into the board. We immediately are going to hit that with an A/B switch so that we can select between the two inputs coming into the signal path. These collapse down into one signal, and that'll flow into our tuner, which will allow us to mute at the input point, but also affect either input. From the tuner, we're going to go into a loop switching pedal, which is a single passive loop switcher, which engages one loop on or off. So it's either bypass the entire loop or go through whatever we have in that loop. And that's going to be the way that we accomplish adding or subtracting all of the effects pedals we'll use on the electric guitar from the signal path while we're using the acoustic. So right now we have the A/B switch, the tuner, and then the loop switcher, which will bring in all of those effects we're going to throw into that loop. From the loop switcher, we're going to go out of there into the volume pedal, and that'll let us adjust the volume. We're not necessarily going to use it for gain adjustment because we're going to be going into a direct pedal setup here, and we have a UA Dream 65. We're not using the volume pedal to adjust gain from any of the pedals in the loop. We are simply using it as a volume control into a very clean set Dream 65. So after that volume pedal is going to come our Dream pedal, and then after the Dream is going to come the HX Stomp, where we have set up some stereo delay and reverb effects. After those, we go to the outputs of the board, and that wraps up the signal flow planning for this project. Since we wanted this board to be made as simple as possible, we did not dive into the world of MIDI or anything programmable from a signal flow standpoint. Instead, what we did was condense the orientation of the pedals in the pedal board so we can select things as easily as possible, knowing that the order the pedals appear on the board don't really matter because we're going to wire them in the appropriate way, in the way that we've planned in our diagram. And this is the typical amount of planning that I'll do for any pedal board project because I want everything to fit, we want to spec the right components, we want the board to work for the client, and we don't want to run out of any parts, we don't want to run out of any time, and most importantly, we don't want to have to make that call and say that this pedal board is going to cost way more than we initially thought it would. So now, on to the build. The starting point for the West Coast Pedalboard DIY kit. It's probably my 4th or 5th board I've built through these guys. They make great kits. But you open the box, which I already opened. It was professionally packaged. Everything was protected really well and shipped really well. And it just comes with everything from the board to the tweed or fabric of your choosing, the other half of the Velcro that's going to stick all the pedals on. You'll see that in the install. And then all of the electrical components that we've spec'd for this build. Alright, so one reason why this is going to be an interesting project and a little bit more upfront planning than previous boards that I've made from a interface standpoint here is going to be, he plays a keyboard also. Plays guitar, plays keys. And this is his keyboard stand right here, the bottom of it anyway. And the request is, can this board sit on top of the legs of the keyboard stand? Something like what you're seeing here. He wants to basically put this underneath so he's got the pedals really accessible. So when he grabs his guitar, he's still right behind the keys, he's got his guitar, and these are almost in the same, very similar to a position you'd be familiar with foot pedals on your keys anyway, so it's kind of all really accessible. That just means we have to make sure this is elevated enough, or what I plan on doing is carving out a channel of some sort to allow extra clearance. Good thing though, this pedal board already comes with some feet. We're going to screw these onto the bottom of the board, which is already going to give us, or if we take away a little bit from the crush aspect once you screw these up onto the bottom, about 3/8 of an inch. The height of this leg at its worst, because it gets shallower toward the end, at its worst is 1 1/4 inches. So we have to make sure that we have 1 1/4 inch clearance, so 1.25, and we're given 3/8 of an inch. So if we take out 0.375, which is the equivalent of 3/8, we are left with 0.875 is the required channel that we have to do. Yeah, so that's 7/8 basically of an inch that we have to cut out. And the issue, so even let's just take 7/8 roughly and give us a guideline here across the side. Just do a couple different measurements here. Like 7/8, 7/8. So this is roughly the height. I don't know if you can see it in the camera. It's about that much that we're going to be taking off the bottom. It's fine. However, the setup going on the board isn't as simple as let's route out a side. We have to make sure we're going to have power going into the board from an IEC connector on this side. This harness that remains will be on the underside of the board, so don't have to worry about that. We have to make sure that the leg doesn't hit the one-spot power block here, power distributor that'll be underneath the board, somewhere like that, but we can measure to see where it has to be. And then I also have a stereo out. The system coming out is a stereo out from a Helix HX Stomp. Well, from an HX Stomp. Stereo out. So we're going to have 2 of these cups. So that means if we were to just factor that, we know this is going to come out. So that's approximately... Now, we do have to watch out from a height perspective, just from the standpoint of this being metal. So we don't want any inadvertent contact with any of these wires underneath, or any other wire. I'm not worried about signal or power, because underneath the board I'll be tacking all of that up with cable holds, standoffs, wire ties, and similar. It's not going to be too bad. So, will we hit the one spot is our only remaining consideration, because what we've found is that pretty much, and I'll end up measuring this out to be exact, but we're pretty much going to have 2 cups in our IEC mounted like that. So the request is to be able to do something like this, something similar here, which puts us at, let's see how long this leg is in general. From here, the leg is 12.5 inches. So if we were to lay this out like this, just to give us an idea, because we're going to actually end up sinking this much farther back to get the angle he wants. So I'm not actually worried about anything until about here. Where's my little golf pencil? There we go. Generally, if we could have a cutout from here down, we're going to be successful with it. The question is, what will it knock into? So if we look at 12.5 inches in line, puts us about here, and we know we're going to clear this back edge. Puts us only at about here, which means, so So even call that 10 inches from the side. As long as we keep the one spot more than 10 inches away, there is no contact that's at all possible. So the question of, will this get in the way underneath once it's mounted under there? Not as long as we keep it here or over. And I mean, just for the sake of verification, it's going to be the other side, 10 inches from here. So as long as this one spot is mounted up underneath on this side, we can carve this out just as we plan and have no issue. This is good. What this is going to let me do, because of the real estate available here, here's our dry, roughly our dry layout, I won't have to have cables that protrude out from the backside. I like to have as little cables extend outside of the board, just from the standpoint of, like, if you go and bang it against something or scratch it or otherwise lift it up against something, you're not doing that against a cable or against a connection. So longevity is greatly helped in that regard. So now we figure out where we're going to want some cables, and we have power and cables that come on top side of the rat. Then we got side entry and exit, side entries and exits, power. This guy needs one cable because he's just an expression pedal, and he's a passive expression pedal, which is pretty sweet. But I'll cut a channel up here in the event. This is going to end up being empty real estate that we could use for, could be used for expansion room. So I'll make it so that this could always shimmy over, and I'll give an access channel so that we could easily run cables in the future if need be. You also have to remember where our power supply is going to be underneath, because putting a channel, we have two options. We can either put a channel and drop the power supply with spacers to allow cables to go underneath, or we put the channels in a location that the power supply isn't going to be in. So we'll put a preferred channel location, and then put the power supply up here, draw it out, and say, okay, in order to be around it or know that we have to put spacers, here are the other considerations. Once I grab the router to make the channel, may change my mind. Also knowing that it's not like these channels are visible. You'll see why once the felt goes on. But, okay, so we're looking at this rough layout. This is going to be our very coarse look at the layout of cutouts in this board, and right now it looks like nothing. It's like a couple lines. And so by the time I'm done figuring out where all the pedals lay out and where all the wires could go, you saw the dry run with the pedal fit, and figuring out where the power supply is going to land, I pretty much draw out all of where the channels are going to be and what I'm going to cut out. And you won't see these channels from the top because the fabric will be on top of this with just a slit so you can push cables through. But does give you a really good idea as to the design of what these slots are going to look like.